How's it going, everyone? Welcome back. Oliver Gonzalez here. Today is very interesting because we're gonna look at RxJS. And what is this? If you are not familiar with JavaScript or any of these kind of concepts, or at least you are familiar with JavaScript but not with this particular library, it's all about observables. And this is part of this course taught by Kyle Simpson when we think about or rethinking synchronicity in JavaScript. So to understand is that not only as JavaScript developers, we need to write all of this set of instructions for bringing interactivity to user interface on the web, but also to actually now handle this concurrency that happen in our applications. All of these tasks that overlaps at a time. And this is something that is not new. This is a problem that in the 60s, 70s, and the 80s, mainly in the 60s, according to Butch, oh my God, what is the name of it? Grady Butch, okay, where he has now, or where he was invited on a podcast from the Pragmatic Engineering, and in there, well, they now elaborate a little bit more the history of the computer science, especially on the initial era that were focused mainly on defense. And now on the thing is when all of this complex systems happens. And because initially it was to build now monolithic application that work only on these machines, all right? With the surge or with the rise of this interconnectivity, or especially with ARPANET, which is the precursor of internet, now we face a new paradigm of programming and computing data. So this distributed systems, right, now emerge some challenge as well as patterns for. So because those particularly pattern in the context of JavaScript are now using callbacks, which is some timers that provide the web platform or the server side, you can now go and use all these callbacks, but as we develop our applications and we need to face more and more complex scenarios, we end up having that callback is not enough to represent what we need to do in our daily life as developers. So it fell short to represent now these complex situations or scenarios that we need to. So even though we went through callbacks to understand now what it does, which is defer or now is the continuation of this set of instructions at some point in the future, and that now introduces some sort of issues. One of them is the inversion of control, because you are now delegating this set of instructions to be executed at some point in the future. So you are now passing control, the inversion control, to whoever is going to handle that. Make sure that actually, do that not too many times, not too few times, not too early, not too late. Don't solve errors, preserve the data, context, and so on. Right. So this generates now these trust issues in our development, and also they are hard to reason it, because after all, JavaScript, since this is a single thread language, we evaluate line after another, another, and this is how our brain plans stuff. We tend to think that we are multitasking, but the reality is that, at least cognitively speaking, we are more concurrent, right? So once we plan stuff in this sequential blocking fashion. So because callbacks not only is not intuitive for developers, despite that it has something called as the pyramid of doom, this is not the issue because when we need to fire up this AJAX request, when we need to communicate with these different computers, all right? Again, remember, we are dealing here is now not only with monolithic applications that's going to run on one application or one computer, but now they will run and they will communicate to other computers. So the problem here is the distributed computing. Now, because of that, you need to actually have some sort of coordination, time coordination, right? It's like, hey, when the things come here, I want to now wait for that to come back, and also, for example, so if you're firing you're firing 3 AJAX requests, so you're communicating with 3 different computers, so you need to wait for all of them to come. You need to wait for their response, okay? So time coordination is one thing, and it's a big deal. Time coordination. The other is once you get that data, you need to actually process that and then show them to the user, or in this case to the developers, in the order where they were called, and that is quite interesting because even though, right? That Jesus, okay. So even though that with callbacks you can do that, and we also look at how to do that by creating a closure, and the disclosure now, or creating a global variable where you're gonna keep track using a hash map all of these incoming requests and handle properly, and then show them in the correct order. So it requires a lot of work to do, and there are no guaranteed that, as I mentioned before, it generates all of this trust issue. With the idea of thunks, where now, as we mentioned before, we have now all of these time-related issues. So we need to wait for this server to reply back or to give us a response, and there's another one, there's another one, there's another one. So we have now a time coordination problem that now thunks say, hey, let's go to eliminate time as a concerning factor by passing now a callback to that when you get the data. So function at the end or thunks at the end of the day is just a function that allows you to now is prepare or call a function with everything that it needs, and then anytime you call it, you get the value out of it. So asynchronous callback, and I'm gonna make a quick recap here, right? So asynchronous thunk is a synchronous thunk is something like this. Let's say you have now a function. You say this is the function add 2 numbers, add, all right? You have x and g, all right? Where this we're gonna return is now x plus g, makes sense? And then you will say, hey, I'm gonna define another function which say, hey, add 15, okay? That whatever value that you pass it, g will be if 15, right? So it means that g is plus g, right? So because this is the presets or these functions that we want to provide with everything that it needs to, let's say for our case, in the thunk, we say, hey, this thunk, it'll be now a function, okay? It's gonna call this thunk here. So this function is gonna be now, or this thunk will be is the wrapper function around a function with everything that it needs, and in this case add with whatever value that you pass here to this, let's say with everything that it needs to say, hey, let's see, hey, this is add 15, all right. You say add 30, all right. Where you say, hey, 50 plus 50, this is 8. So a function that you pass that way, a function that you pass everything that it needs to, all right. And every time you call it, you're going to return is that. So add 30, right? Now, the thing here is that anytime you now is call your thunk, all right? The good news of this is that you always get the same value out of this. You know, you may wonder why this is useful. This now act as a token that can be shared across different locations in your program. And this token, when you now combine that with asynchronous programming, let's say, hey, now you want to create is an async thunk, okay? An async thunk, where now here you say, all right, so let me, by the time that I run some asynchronous operation, let's say after 1 second, all right, I want actually is to now call the callback that you're gonna pass here. So in other words, here you say, hey, let's go to define now this add async, all right? Wrap then this into a timer. So, hey, set timeout here, and I want you after a 1,000 second run this callback here that I'm passing here, okay, and return those values here, okay. So by the time that now I define this async thunk here, or call that, so I'm gonna pass now a function where I'm gonna get that value out of this, which is, hey, I want you to now call async, all right, where this preset define values plus the callback, and it's inside of this, okay. When I'm going to now call the callbacks here, say, hey, now the callback here, it'll be pass this data down. So it means that in this callback, by the time that I get that value, I say, okay, now give me that data, and let's go to console log that data that you get. In this case is 50. 30, my bad. But as you can see, now this async thunk is gonna wait for that. CV is not, oh, exactly, my bad. But after 1 second, so ignore this content security policy because it's now the browser is screaming here. But after 1 second, you're gonna get that value. And this is huge because now this thunks eliminate is time as a complexing factor. And even though that this doesn't solve the problem of inversion control, but now we don't have to worry about now time, as I mentioned, as a complexing factor. So, because this is something that is being used in the programming for years, decades, right? It still now has this trust issue that we need to pass down with a callback, right? This set of instruction that, well, at some point it will execute it. That, because what happened here is that this callback here, this callback that we're passing here, is being executed here. By the time that that's set timeout, whoever is going to run that code after 1 second, do that. So not only that, but luckily for us, now with the programming language called E, that was written by Mark Miller and some of the TC39 members of there, where in that language, of course, they have now this particular problem to deal with the concurrency, and they come up with this thing called promises, where now is around an idea that we need some sort of placeholder to wrapping. We need a placeholder to eliminate time as a concerning factor, wrap around a value. So in other words, is that by using now promise object here, and you can think of this as some sort of subscription callback manager or event listener, all right? So by the time that now promise object is created, here you're gonna pass in some function that is called the executor, okay? Where you're gonna get is the resolve and the rejected, okay? Which means that by the time that now this promise has been resolved, which promise fire only once, now I want you to say, for example, is this. Hey, set timeout. So set timeout here, and then you say, I want to now run this callback as resolve. All right. I want to run this callback as resolve after 1.5 seconds, right? So we can assign this into a variable here and say, hey, do promise 1, okay? And here we define, this is the setup function, and then we're going to now define is the place where we're going to now subscribe to, right? With the .n. So here, when that happens internally, so when this object actually detect that now, after the next amount of time, this resolve callback, or this resolve callback is being called, all right? Which is this promise has been resolved, all right? Now I want to get that data, and you're gonna get that data here by subscribing to the .n. So here you're gonna get the data. Here the data. Right now we're not defining any data. What's going to define is this 42, and then you can now console log this. Right. Data. So after 1.2 seconds, you're gonna get 42. And this internal mechanism to actually coordinate that is something huge, because now we can not only represent is this data, this placeholder that we need to eliminate time as a concerning factor wrap around a value, but also we can compose the keyword here is important, compose several of these promises, several of these asynchronous stuff that happen, these concurring things that can happen. And that's huge because you say, hey, const p2 here as new promise. You're gonna actually mimic this a little bit, all right? And here we're gonna say, hey, the first time is 10, and the second promise is 32. Of course, this will, you're gonna complain about it. Let's say P2, and then P3. Right, let's go to subscribe now, P2. Okay, and you can now is change these different promises. So you need here is to return now is the you need to return is a promise here, promise 3. Okay, so by the time that now this promise internally resolve that, then you can subscribe to whatever is being called now here in the data. Okay, and then actually print that log. That. So now this will say, hey, I'm going to print is 32 for that. Say, hey, console log this. Say console log data, right? Then it's printing 32 there. So the point of this is that we can now describe, which is very important, describe is not only flow control, but also data flow. One of the problems with this is that since this now solves the inversion control, because now we're not passing a callback to that, and we have now some of this guarantee, even though that we are passing is now a callback, all right? But we have now the guarantee here that promise will fire only once, is not going to do that too many times, too few times, too early, too late. Don't swallow errors, don't lose data context, and all that kind of stuff. So this now promise give us is this assurance. So give us the trust back for that. Now, good. The problem with this is that, for example, if you want to define some sort of functions, let's say is, well, so handle promise 1, all right, and then handle promise 2, okay, and if this piece of code actually lives in different locations in your code bases, what ends up happening is that now you have this non-local, non-sequential reasoning, because now you have to go back here and then move through that file locations, read that and understand that, all right? So what is the next handler here? Okay, this might live in another file. So you have now to jump into different location here. So again, promise now solve this problem of inversion control, but not the sequential and non-blocking reasoning. And also provide us this way of flow control and data flow. Now, since this is the way how you can actually call functions, and because with promise, it allows us to compose all of these different operations that we can do. This is coming from the functional programming. So promise is now a monad at the end of the day, and I can describe a monad in terms of one use case, which is the way to model is state change. That's all. That's all. Don't ask me too much. So for example, Redux actually help you to do that. So Redux is somewhat a monad promise is a monad, but the TLDR of this is all of this weird concept. Oh my God, all of this weird concept comes from the functional program. This is known as also point 3. So as long as this argument accept the same data points or the same arguments, it's gonna run that. So you don't need to actually do this. And this is now getting to the realms of functional programming. Again, what we really care about in today's video is the observables. So then, because we want to solve this generator problem or this non-sequential non-reasoning problem, and since functions run to completions, normal functions run to completions, we need a certain behavior that allows us is to somehow stop the execution of a function. This is not to bring chaos to the language. This is in fact is to promote now, or to give us the ability to syntactically describe is a state machine, which is with generators. And the way to describe that is by writing a function with an asterisk. And here, with generators, the point of this is that anytime you run this and it finds a yield keyword, it will stop the execution of this function and then pass control to whatever this function was called with the data, right? It's a yield 50, a yield 10, and then 20, and then you get the idea, right? Exactly, and then you get the idea. So this actually going to return now an iterator. And an iterator, for those who are not familiar with, is this way to stepping through typically a data set, in our case through a flow control execution through the next through the iterator interface, calling the .next. Okay, and if it wants to get the value out of that, we say, hey, give me the value for that, right? Iterator.next. Wait, what? Oh, okay, because this is the function declaration or the generator declaration. Okay, I get it. This is the generator declaration. That's what happened. This is generator declaration. I'm gonna call this is flow. All right, and then now you actually is call flow, and then is where you can have access to the next and retrieve the value. But as you can see, now whoever now controls this iterator can have access to that, and it reached that too until the function is not executed anymore. Now, the interesting part of this is that you can now here in your flow generator, which not only act as a message in passing, because you can actually pass some data here to that, and then it's going to receive that after it resume the function execution. There's some caveat here. For example, if you want to pass that at the first time, it's going to evaporate that. But well, the point of this is when we're writing is our asynchronous functions. Now, this is very compelling about this. How so? Because, well, with this we can say, hey, this is a new flow, and here's when we can define is our async operations behind the scenes. So for example, say, hey, I want to fetch this data. Let me actually see, placeholder, that's right. Placeholder, I think, is with user, exactly with user, but I don't want all of them. I just want to have at least one, right? That'll be good. I want to now fetch this data, okay, where now this will return a promise, okay. So the first time now we're getting here into these functions, I want to now run these operations, and by the time that that promise is resolved, I want to resum to this function execution and give me the data out of that. So assign that value that I'm getting to a response initially, okay, object, which is the way of how you can now receive streams of data, and because you are receiving streams or chunks of data from the server, then you need to say, hey, once you receive all of these small chunks in a unsigned integer of 8 bits, okay, once you receive this, I want to now transform that into a human readable format, which is JSON. So hey, because this JSON stuff is something that happened asynchronous, so now JavaScript say, okay, let me now add this particular task to the micro task queue, and from there say, okay, now after I evaluate the code of that file, I'm gonna ask the event loop if we have anything on the micro task, which has more priority than the callback queue. If it is, okay, pass that to the call stack and evaluate that. And once you evaluate, okay, which contain is now the data, all right, I want you to now is pass and assign that value to this identifier called data. Okay, so you might wonder, is like, okay, that was quite interesting. We need to actually deal here. Okay. And remember, with generators, this gives us the ability to create these flows of data, which is a great thing. And now, okay, yeah, which is a great thing. And now it is time to actually trigger this generator, or this generator is this pause and resume, pause and resume. So the way to do that is by actually now calling that new flow. We're gonna get an iterator, all right? And because the first time of this iterator, we get in here, we get into the function execution, it finds a yield keyword, it frees the function, and then pass control to whoever control that iterator. In this case, we're gonna get the value out of this. And because this value the first time is now a promise, okay, good. Now let's go to store this, for example, into a future data, right? Future data identifier. Okay, so because now future data at the end of the day is a promise, okay, so we need to actually wait for the data to be loaded with the dot then, all right, and once that is done, once that is resolved, okay, we're gonna not only get the response, okay, response object, and you may wonder, how can we resume the execution of this function to get into this new flow generator? Well, we say, hey, whoever controls the generator now is going to pass this response value to this, all right? So now you resume the execution with this value, and that is assigned to the response, okay? It's going to continue evaluating is that statement and say, oh, I find now a yield. I'm going to pause that, right? Which is in this case is going to return is a promise. So we can say, hey, because we're returning a promise, and promise can be changed like that, this data flow and flow control, as I mentioned before. Then I can say, okay, now once you get this, remember that this promise is now from the response.json. Once you get that streams of data in this unsigned 8-bit transform into a JSON as a data, all right? Now I want to actually well, it's gonna call here this, and I want to console log that data. Okay. So let's go to now get in again to the function execution generator, but this time with the data, and then it's in there, we're gonna print that. And I don't think this will work because there's some variables defined, but now it will. This is the way of how now async work behind the scenes. And this is huge and massive to understand this particular mechanism, because not only that we solve the problem of non-sequential, non-blocking, and non-local, non-sequential reasoning about it here, okay? But the question is, what happened when the source of data, the event source, now send us is a series of data, right? And we need to actually model that, find a way to actually capture all of this string of data. So for example, not only on the server, but also for user events, for example, click, all right, or any user events. So whether it's click, mouse, wheel, mouse over, typing, key up, key down, you name it, right? So how can we now deal with this? Can promise help us here? We went the promise at the end of the day, it doesn't solve that particular problem, because now we cannot able to separate is in a easy way the setup. This way, the way how we're starting to define is the way or starting to define is the source of our event, and in a separate place with consuming that. And not only that, because promise only works once, so you need to actually define is a coordination of promises. So again, anytime we need to define is coordinations, it requires a lot of work. It requires you to define a closure, and that closure actually you keep track is the different the promise that is currently being evaluated. You can define is now in a collections of all of those promises that being evaluated, and then if you want to expose that to the external world so they can consume that, now all of a sudden you are at the beginning. All of a sudden you are at the beginning. So that's huge. That's interesting. And this is when now we're starting to look at observables. When now observables is not native to the language, we're gonna see now a library called Redux that allow us to handle or to describe the need of a model, or we need to model. We need to model is that an event or a data that come from an event source, one single unit of that, pass through a series of steps and propagate throughout the system. So that's when we slowly but progressively look at the observables here, because now Kyle Simpson is promoting their own particular library. I don't have anything against that. But what I prefer to go with is with the idea of this main library that now is being written by smart folks at Microsoft to actually help us with that. So the idea of Observable is pretty much like an spreadsheet where you have all of these different cells, right? And you can have now values or computer values there, or calculated fields. So you have, let's say you have now in C1 the value of 10, and in the C2 now the whatever value is on C1 add or plus 10, and when you hit enter it actually compute that or calculate that, so give you the value. And then you have now a cell C3, then you say, hey, whatever value is on the C2 I want to so whatever value is on the C2 times 3, right? And as you can see, all of these chains of calculations where now whatever value was changed along the chain, it can now automatically update the previous one and the previous one and the previous one. So this change of computation that is pretty much the same way of how can we model is our event-oriented systems, okay? So because now an observable is a way to model the need to receive a single unit of data from an event source and pass through a series of steps to propagate its way to the system. So you can think of this, so if I boil down to an observable is an adapter hooked onto an event server in cases. An observable is an adapter hooked into an event source and produce a promise every time a new events come through. This way of thinking here is quite interesting, especially for, technically speaking, as JavaScript developers, with this observable. So it's a way to, so it's an adapter hooked onto an event source that promise every time an event comes through. And that's huge and that's massive, bro. You know? That's huge and massive. So, but it does that in a separate way. So you can set up your event source and then in a different location in your program, the data flow. So this is a programmatic way to represent that visually. And I know that I went through, describe briefly all of this. But now let's get into what we really get in today's video.
Hi, my name is Steve Kinney, and I'm the front-end architect at Temporal. RxJS
Oh, you are now the front-end architect at Temporal. Oh my god.
is a really useful library for managing events that happen over time. In this course, we cover RxJS from the very basics and work up from there to solve common UX patterns. We'll look at how to create observables using some of the built-in utility functions, as well as how to test them. We'll look at operators.
Okay.
How to create observables using some of the built-in utility functions, as well as how to test them. We'll look at operators for manipulating data, manipulating time with our observables, and eventually orchestrating across multiple API requests. Towards the end of the course, we'll look at how to solve common UX patterns that can be otherwise tricky in vanilla JavaScript. I hope you enjoy the course. So I am going to kind of take this for a spin real quick. So I have this very kind of simple.
So let's get into this then. When this was deployed? Oh, 2022. Okay. Good. It's a really useful JavaScript library for managing events that happen over time. A good way of this. So this is a library that allows us to handle events. That allows to handle events, or for managing events. This is a library for managing events, okay, that happen over time. So using is now DRX. So here we're now going to take a look at this specific API, okay, because even though that observable is not native to the language, and it seems that now are in the draft. This is something that they don't going to land to the language any soon. So for that, because we need to solve our own problems, let's get into this to the area.
Example right here. Temporal. RxJS is a really useful library for managing events that happen over time. In this course, we cover RxJS from the very basics and work up from there to solve common UX patterns.
Because that's what it is. So this help us to cover most common use cases, UI patterns. And not only UI patterns, but also is any event base or any this way to model event as a single unit from an event source and then pass through a series of steps to propagate in our system, distribute in our system.
We'll look at how to create observables using some of the built-in utility functions, as well as how to test them. JS from the very basics, and I'm the front-end architect at Temporal. RxJS is a really useful library for managing events that happen over time. In this course, we cover RxJS from the very basics and work up from there to solve common UX patterns. We'll look at how to create.
Okay. So we'll look at how to create observables, okay, using the built-in tools or utility, the built-in utilities.
Create observables using some of the built-in utility functions, as well as how to.
So the built-in utility functions and how to test them. Okay. It's not only design observables, how to create them and how to test them.
How to test them. We'll look at operators for manipulating data, manipulating time with our.
Okay. We'll look. So yeah, we'll look at manipulating data and time. We'll look at manipulating data and time.
Observables, and eventually orchestrating across.
With observables. Okay, with observables, and eventually orchestrating across multiple APIs, and eventually orchestrating, and eventually orchestrating across multiple API requests, which means is that how now we can is consume from different source of events, from different and orchestrating across multiple API requests. Because another problem here is that this is from one source, but how you cannot deal with multiple source, you know? But in any case, right now we're in an event source that give us is a streams of data. So
multiple API requests. Towards the end of the course, we'll look at how to solve common UX patterns that can be otherwise tricky in vanilla JavaScript. I hope you.
So let's get into this. Fair use. You're not gonna see this. So it's a shame for you, might be or not. But let's get into this. Oh, this is the introduction. Let's get into this.
Hello, welcome to RxJS Fundamentals. So this is an intro course on how to use RxJS to solve some common problems. With that, there is no expectation that you've used RxJS before, so that's good. We're also going to be completely framework agnostic. I know that a lot of times RxJS is associated with Angular these days, but you can use it with anything. I've used it with React and Redux before. I use it today in the Svelte app that I work on. It is, at the end of the day, just JavaScript. So we're going to play with it agnostic of any framework. And again, we're going to start from the very basics and kind of build up an understanding. Because in my experience, there's a lot of great content on RxJS, but a lot of times it's like, let's go into some conceptual understanding of marble diagrams, and then all of a sudden it escalates quickly until there's 7 nested observables, and you're like, I want to cry. So we're going to take things very slowly. We're going to build up each.
It's because it's a scalability. It's because, and I am looking at this is because since this is something that is going to take I am just as much as possible try to safeguard me from the future, to prepare me from the future for what's coming next.
Piece as we get to some more sophisticated examples towards the end. So we will kind of play around with some basic unit tests to understand how some of the fundamental parts of RxJS work. We'll start building some very kind of simple interactions in some applications, and then we'll solve some of the kind of common UX issues that come up that RxJS is just really well suited to handle. In a lot of cases, like applications, some basic unit tests to understand each diagrams, and then all of a sudden it escalates quickly until there's 7 nested observables, and you're like, I want to cry. So we're going to take things very slowly. We're going to build up from each piece as we get to some more sophisticated examples towards the end. So we will kind of play around with some basic unit tests to understand how some of the fundamental parts of RxJS work. We'll start building some very kind of simple interactions in some applications, and then we'll solve some of the kind of common UX issues that come up that RxJS is just really well suited to handle. In a lot of cases, you don't necessarily need to use RxJS for everything. So part of this is understanding where a simple promise will do, and where you might end up in a situation where things are getting a little squirrely. At the end of the day, anything you can do in RxJS, you can do in regular JavaScript, because RxJS is built in regular JavaScript. The big question is, should you? Right? Enough of these things where you start reinventing the wheel and throwing global variables or even module-scoped global variables everywhere, and then eventually you and your team develop a deep resentment for you, which I'm going to try to save you from during this. So let's just talk. We're not going to do a whole lot of the kind of conceptual theory here. I want to start getting our hands dirty very, very quickly, but let's do just at least a high-level understanding of what's going on. What is RxJS? What did you just sign up for? What are we going to be talking about for the next little bit?
What were you just signing for?
So, and I stole this quote from the RxJS documentation. You can think of RxJS like Lodash for events. In Lodash, we have a lot of helper functions for dealing with arrays and objects and all of the stuff that just comes with JavaScript not really having a standard library to speak of, right? So Lodash gives us a bunch of utility functions. Yes, you could write them yourselves, but a lot of times if you want them kind of tweaked for performance, everything along those lines, using a battle-tested library makes sense. RxJS is basically dealing with that, but things that happen over time. And you're like, okay, like what? Well, if you think about it, the way that our applications work is we send the code to the browser, we send some HTML, loads up some CSS and some JavaScript, we render an initial page, that, the traditional web page, right? And then really everything that happens after that, right? As soon as we load up that HTML page and run through the initial scripts, the event loop kind of just sits there and waits for stuff to happen, right? And all of that stuff that can happen is an area where there is a chance that RxJS might be helpful depending on what kind of problem you are trying to solve, right? Things are going to happen over time. Arrays give you a collection of things all at once. You can work through the array, you can map over it, you can filter it. But if those values come in over time, maybe through a series of click events, maybe through a timer, maybe through an API request, right? Yeah, you can load it into an array, recheck the array, or we can just kind of think about things as streams of events happening in our application and write code around that as we go. So there is an abstraction for asynchronous values that is now in the ECMAScript standard, and it's called promises.
Promises, exactly. There is now an abstraction for handling async.
Things as streams of events happening in our application, and write code around that as we go. So there is an abstraction for asynchronous values that is now in the ECMAScript standard, and it's called promises. And promises are great. I love promises. They're wonderful.
It's an eventual value.
The problem with promises, and this is not really a problem with them, it's just what they promise to do, is that they resolve to one eventual value.
Exactly.
Right? And so you have a promise for this one API request, or
where
one
now
thing that happens, it becomes a value. Now imagine programming without arrays or objects, right? It should be a series of like go-to statements. You could figure it out. It'd be great. But the idea of having this idea of a collection, right? You can think of a promise as one eventual value. I think a really good mental model that could be helpful.
So a promise and eventual. Okay, so Rx is like Lodash.
An array of eventual values.
For events.
So promises for one, just like
exactly.
a
promise is an eventual value, and a observable is a series of eventual values. But this is quite as a way to recap.
Lodash gives us a bunch of utility.
Right?
Yeah, like, okay,
because
JavaScript.
Especially once the browser sent, or once the server now sends.
Render an initial page. That the traditional web page, right? And then really everything that happens after that, right? As soon as we load up that HTML page and run through the initial scripts, the event loop kind of just sits there and waits for stuff to happen, right? And all that stuff that can happen.
So the event loop can kind of sit there and wait for events to happen.
Is an area where there is a chance that RxJS might be helpful depending on what kind of problem you are trying to solve, right? Things are going to happen over time. Arrays give you a collection of things all at once. You can work.
But it's like that. This is describing the critical rendering path. So after now the browser renders the entire HTML, CSS, and JavaScript, now pretty much that website is, so the event loop sits there and waiting for events to happen. So now observables are a good way to describe now this series of events
through the array.
So pretty much like you can imagine.
But if those values come in over
like
time, maybe
arrays
through a series of click events, maybe through a timer,
in your application. So if you want to represent now collections of data where they are all at once.
Of events happening in our application.
But now how you represent is now these streams of data.
So there is an abstraction for with promises, and this is not really a problem
or a
with them.
series of eventual values.
They promise to do. Now imagine programming without arrays or objects, right? It should be a series of like go-to statements. You could figure it out. It'd be great. But the idea of having this idea of a collection, right? You can think of a promise as one eventual value. I think a really good mental model that could be helpful is thinking about effectively an observable as an array of eventual values. So promises for one, just like a primitive, like a number or a string, or even a JavaScript object, is one object, and an array can be a set of them. A promise is good for one value. That could also be an array in this case. An observable is things that are going to happen kind of over time. So let's talk a little bit about what some of those things might be. We have APIs, right? And yes, you send a promise. Go get the JSON or what have you from an API. Great. But there's a whole bunch of like edge cases, like you want to refresh, stuff along those lines. So promises are great for a happy path. You even have a catch in the case that it doesn't work out. What if you want to retry a certain number of times? Okay, well, yeah, you could maybe like keep a like a value somewhere in scope and just try to iterate it and then write an if statement, so on and so forth. And you can see how this things start to get a little squirrely. What happens if you want to reload
A little squirrel.
the value
A little
somewhere
odd.
in scope and just try to iterate it and then write an if statement, so on and so forth.
A
You can
little
see how this thing starts.
squirrely. Squirrely. Oh my god, what in the F? I'm learning. Squirrely. Oh my god. That's what I. Okay. That's why. Okay, squirrely. Oh my. Okay. 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 So what happens when things go wrong? Okay. To get started, let it squirrely. Squirrely, man. Squirrely.
Start to get a little squirrely.
Squirrely. A little squirrely. Oh my god, what in the F is this, man? A little squir. Oh, exactly like an. Oh. Squirrely. Oh. 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 Oh my god. Squirrely. Oh, nigga. Oh my god. Alright. Oh my god. Okay, I must admit. Looking at the RxJS fundamentals from Frontend Master, taught by Steve Skinny. The world squirrely now is my favorite. So the word squirrely and stochastic exactly. Stochastic. Oh man, I love it, man. Stochastic, exactly. Stochastic. Are now part of my collection. The word squirrely and stochastic are now part of my collections. Are not part of my collections. street and academia together. The street and academia together, man. Oh my god. Okay, I really love it. Oh, nigga, I love it. Squirrely. Oh shit. Oh my god. Oh nigga. Uh, okay, move on. Squirrely. Squirrely, man. That's what happened when you now started to define your promise. Okay. That's what happened when you started to define your promise in a event source, in a series of event source, right?
You even have a catch in the case that
Ardilloso así. Squirrely. How do you? Squirrely. Squirrely. In Spanish. Exacto, como una ardilla, marico. Como una ardilla, marico. Like squirrely. Oh my god. That was quite interesting. Definitely quite interesting. Definitely quite interesting.
it doesn't work out. What if you want to retry a certain?
Ooh.
number of times. Okay, well, yeah, you could maybe keep a value somewhere in scope and just try to iterate it and then write an if statement, so on and so forth. And you can see how this can start to get a little squirrely. What happens if you want to reload the data at a regular rate? Okay, now you can do a set interval, and you can aspire to clean up that interval and hope you get it right. But you're also matching that with now the retry thing that we just talked about. What happens if you want to reiterate across a paginated API, right? A lot of times as front-end engineers, the reason that I'm employable is because for a lot of the UIs that we want to build, the APIs don't support that. So I have to do a bunch of, right? A lot of times as front-end engineers, the reason that I'm employable is because for a lot of the UIs that we want to build, the APIs don't support that. So I have to do a bunch of Rube Goldberg machines in
Rube Goldberg machine. Rube Goldberg machine. Oh my god, this has a name? Rube Goldberg machine, bro. Rube Goldberg machines, bro. Rube Goldberg machines. Oh man. Okay, Rube Goldberg machine. Rube Goldberg machines, bro. That's interesting. Rube Goldberg machines. Rube Goldberg machines. That's the name of that. Oh Jesus. Rube Goldberg machines. Okay, currently in Rube Goldberg machines. Interesting. Rube Goldberg machines. Something for nothing. Oh my god. Sorry. Rube Goldberg machines.
Get to come back to pick up his tip, and he'd lose his professional standing. How does this door opener-upper really work? It's very...
To me, that's quite interesting. The way that transatlantic accent of a lot of people in the 40s, they have. And I really love it. I am not a U.S. citizen. I am not anything related to the U.S. Most likely the cultural that we share that, especially with MTV and everything on the 80s and the 90s. But when I dive deep into the history to actually understand you a little bit, the U.S. Citizens and as a history, I really love about the people, how people talk in the 40s. Like that, it's like, hey, it's like they made that as a commercial, right? This transatlantic accent. That's to me why, I mean, one of the thing that I love this is the pace. Is the pace of how they actually are talking to describe something. And this pace is something that is unique in every different language, and each one of them has its own beauty on that. You got the French, the German, even here in Latin America, the Spanish, for example, from Chile, Argentina, Mexico, Venezuela, or Brazil, that they talk about Portuguese. But yeah, I really love this transatlantic accent. All right, something for nothing. Get
Simple.
into this.
But watch close. Now here's what happens. You see, waiter places cat B on pile of dirty dishes A. Now cat B sees mouse C. Of course, this
So cat B sees now mouse C.
is a stuffed mouse because he must be used for the next waiter. Now cat jumps on mouse C, causing lever D to lift
Causing lever D
lighted candle E,
to lead the candle
which
E,
ignites fuse
which ignite
F
the fuse
and sets off bomb
and
G,
sets off.
opening door H very gently. Well, folks, I suppose there are one or two among you who think that my inventions are a bit ahead of their time. A shade fantastic, perhaps. All right, go on and say it. Downright
Wasn't the 40s.
screwy. But let me tell you something. I've got lots of company, genuine inventors, guys who've got their stuff protected by the United States Patent Office. And believe me, some
Patent offices. Oh,
of it needs protection, if you know what I mean. For instance, now here's an invention that was granted patent number 556248 back in the year. It's an automatic hat tipper for the lazy Lothari. Wheels, cogs, devices that have actually been patented. But by far the most persistent dream of inventors has been to get something for nothing. The famous old standby. Of course, you all know that when something is dipped underwater, it seems to lose weight. So this particular perpetual motion machine is designed to have some of the weights in water and some of them out of water at all times. It's all very simple. And so are you if you think it'll work. But confidentially, I've got one that will work. And if you'll excuse me for a few minutes, I'll show you.
To grant a patent without paying for it. That source of trench mortar, all right, but on it we all know. Traps. Gasoline does its best work when it develops more power.
and I get it why, for example, games like Portal and Half-Life actually mock of how people in the 40s talk about. Hello, investors, I know you suck a lot of money, so hey, we are to actually do some work. Okay.
One method of obtaining, several other changes were made to increase power without causing a knock. First, the piston top was redesigned so that it will mix the air and the gasoline together more completely. In the latest engines, the roof of the combustion chamber around the intake valve has been and compressed more for more power. Today, the driver of the motor car doesn't get something for nothing, but he does get more power than ever before from the gasoline he buys. Our available supplies of fuel...
Folks, I've done it. I've discovered the secret of perpetual motion. Yes, sir. Long, long after you and I have departed from this earthly scene, this machine of mine will be working on and on and on and on, never stopping for Sundays, holidays, or bank nights. On and on and on and on.
Okay. It's an extreme sophisticated device to do a very simple task. It's a chain reaction. Interesting. Very, very interesting. Okay. Rube Goldberg machine, and okay. Okay. Okay, okay, oh, right, okay, fellas. Rube Goldberg machines.
In order to kind of get the UI in place. So if we need to start iterating recursively down, yes, you could do that, but could you do that with retries? Could you do that with a regular refresh interval? Starting to pull all these pieces together, like any one thing, maybe not that complicated. Pulling it all together requires a better abstraction so that we don't get lost in our own complexity. So observables can help with all of this. There's APIs don't support that, so I have to do a bunch of Rube Goldberg machines. A lot of times as front-end engineers, like the reason that I'm employable is because for a lot of the UIs that we want to build, the APIs don't support that.
Mm-hmm. And I think that's quite interesting. Mm-hmm. So the reason you are employable as a UI engineer is because a lot of the work we're going to build, the API don't support that. The reason you're employable as a UI engineer is because a lot of the things, or a lot of the UI, a lot of the UIs we want to build, the API doesn't support it. The API doesn't support it, which means that you are hired for maintainability.
So I have to do a bunch of Rube Goldberg.
So I have to do a bunch of Rube Goldberg machines. Rube Goldberg's machines in order to get the UI in place. In order to get the UI in place.
Machines in order to kind of get the UI in place. So if we need to start iterating recursively down, yes, you could do that, but could you do that with retries? Could you do that with a regular refresh interval? Starting to pull all these pieces together, like any one thing, maybe not that complicated. Pulling it all together requires a better abstraction so that we don't get lost in our own complexity. So observables can help with all of this. There's the other part. I used to work at a company that I will not name, but we had this idea of a user, right? And you need to know the current user to figure out what you're going to show on the page. That seems fine, right? And there was an API for getting the current user. However, if you wanted to know whether it was a regular account or a sub account, well, that was another API. Did you want to know if it was part of a team or an individual account? Well, that was another API. Did you want to know if it was a free or premium account? Well, that was another API. So in order to figure out what to show on the page, we had to send out this battalion of API requests and try to orchestrate it all at once. And so we have a lot of situations where to show a given piece of a UI, maybe you have a list index that only gives you the IDs of the things that match. If you want to figure out more data, you have to go hit each one of those individual APIs, right? Coordinating all of that stuff can be somewhat complicated. List index this battalion of API requests and try to orchestrate it all at once. And so we have a lot of situations where to show a given piece of a UI, maybe you have a list index that only gives you the IDs of the things that match. If you want to figure out more data, you have to go hit each one of those individual APIs, right? Coordinating all of that stuff can be somewhat complicated. And so observables seek to help us with that, right? And to help us deal with the common error paths and just give us effectively, ArcGIS is not a framework, but if we think about like a scaffolding or a framework for dealing with the complexity of orchestrating multiple things that could happen asynchronously. So observables can help with this as well. Then there's all sorts of just little like UX quality of life things, right? Like things that pass and just give us effectively, ArcGIS is not a framework, but if we think about like a scaffolding or
okay, this is not describing is all of this being useful.
Pull all these pieces together. You
okay.
So let's do the case that
working with APIs.
Don't you do that?
Exactly.
Requires a company
progressive
that I will not
data
name.
enhancement.
But we had this idea of a user, right? and regular counter. That was in situations where to show a given piece of UI, maybe you have a list index that only gives you the IDs of the things that match. If you want to figure out more data, you have to go hit each one of those individual APIs, right? Coordinating all of that stuff can be somewhat complicated, and so observables seek to help us with that, right? And to help us deal with the common error paths and just give us effectively, ArcGIS is not a framework, but if we think about like a scaffolding or a framework for dealing with the complexity of orchestrating multiple things that could happen asynchronously. So observables can help with this as well. Then there's all sorts of just little like UX quality of life things, right? Like it's usually good to like show a loading indicator, right? And that's fine, but like how soon do you show the loading indicator, right? Because the first time I implement that, this is what happens, is the API ends up being fast, and then I show the loading indicator, it flashes for like a hot minute, and then it vanishes. Right? And so how do you time it? Okay, I only want to show the loading indicator in one situation. Like if it takes a certain amount of time, show the loading indicator, right? But what if the API request comes back like right after I show the loading indicator? Well, even if the API has like filled, I might want to still show the loading indicator for a long enough time that's not visually distracting to the user, even if we're done loading, right? And these are the issues of dealing with events that happen over time and coordinating all of these things that RxJS seeks to help us with. There's all sorts of little other things like dragging and dropping. Right, you have the, like if you think about that problem, you end up, all right, so on mouse down on the element that we want to click, cool. Then I want to set up an event listener that is listening for mouse movements until they release, and we have a mouse up event, right? And then we also have the issue of like where like they're dragging might have other implications in our UI, right? If it's a hover state where they can like drop it in that given area, we might want to show different things. So reacting to all those things and setting up all those different movement events can be super helpful as well. So that's the pitch. That is, hopefully I've sold you on spending some time.
Okay, so that'll be all for this video. Take care.